Welcome back to another fun and exciting Q&A episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
This episode is driven by listener questions where you send your questions to us and we answer them. Well, it's not we, it's Professor Fred Watson who is joining me here. My name's Heidi Campo. I'm your host for this episode. And Fred is our resident astronomer at large. Fred, how are you doing today?
Very well, thanks, Heidi. And you shouldn't underrate the contribution that you make to this show, because I couldn't answer these questions without you being there. And often you are somebody who illuminates the questions in a way that I wouldn't think of, which I enjoy very much. So thank you again for welcoming me to the show.
Thank you so much, Fred. That was sweet. Well, our first question today comes from Patrick. I don't see Patrick's location, but Patrick says, "Hello, Heidi and Professor Watson. What is the likelihood of an object or objects currently orbiting our sun not being native to our solar system? Could they have been rogue objects or perhaps objects from a passing star that was captured by our sun? Thanks for taking my question."
Yeah, I love this question, Heidi, because it has echoes of something we were talking about in the last episode, the object that's not from our solar system that is whizzing through the solar system. And basically, Patrick is right in suggesting that maybe some of the objects in the solar system, and by that I'm thinking of things like asteroids, perhaps even comets that are in orbit around the sun, that are in a closed orbit, that are something that goes around regularly rather than something that just comes through once and zooms away, which is what 3i Atlas that we were talking about last time, that is doing that. So it's possible that there could be things that have been captured. We know that some of the moons of the outer planets are ones that have been captured by those planets from the region beyond Neptune, what we call the trans-Neptunian region, where there are these icy asteroids, which we now know to be very numerous. We didn't know about them at all when I started my career, even though somebody had predicted them in 1950, Gerard Kuiper and his colleague Dr. Edgeworth, can't remember Edgeworth's first name, but they predicted that there would be these icy objects way in the depths of the solar system, and one of the belts of those objects is now called the Kuiper belt. And we know that some of the some of the satellites, the moons of the outer planets, started their lives as Kuiper belt objects. So they have actually been captured by the planets. And so, the scenario that Patrick puts forward of something like that being captured by the sun, having come from a distant object or a distant solar system from well beyond our solar system, it's absolutely possible. And it's the kind of thing, I guess, that people who study asteroids, and there's a large body of interest in that topic now, people who study asteroids perhaps have in the back of their mind, because you can learn a lot about an asteroid by looking at the spectrum of the light reflected from it in the infrared. That spectrum is affected by the surface features of the asteroid. And if you start picking up indications of perhaps a different sort of chemistry on the surface of an asteroid that we wouldn't expect from one of our homegrown asteroids, that might be the kind of thing that would lead you to perhaps speculate that this might have an extra solar origin, something that's come from another solar system. How would you test for that? Well, it's possible these days to run simulations of the way orbits of objects in the solar system have evolved. So you can sort of pick an asteroid, look at its current orbit, and then sort of play it backwards. And it may be that you would do that with an object and find that at some time in the past, its orbit was unstable, which might suggest that it has actually come from another solar system. So it's not impossible, and it is something that I'm sure actively is being pursued by researchers in this topic. So good question, Patrick.
That was a way to break in the episode. Excellent question, Patrick. Our next question is an audio question from Frederick. And I'm going to just give Fred and I a second to cue that question up. And we're going to play that question for you now.
Hello, this is Frederick Arthur Nolde from originally Duluth, Minnesota, USA. My question is, if black holes are evaporating through Hawking's radiation, what is left over? Is it the point of singularity? And could that be dark matter because they are so dense yet very probably small and don't interact with anything? Just wondering if I solved this.
What a great question. And it's one that set me thinking, like so many of our listeners do. If you have a black hole that evaporates, what is left behind? Is it still a singularity? And could that be the dark matter? So there is a problem with that scenario. Well, there are a number of problems. One is that the evaporation of black holes, which exactly as Frederick Arthur says, is caused by Hawking radiation. This is radiation that leaks out of the black hole. That is a very, very slow process indeed. So the timescale for a black hole evaporating is measured in many billions, in fact, sometimes tens of billions of years, longer than the age of the universe. So unless black holes are very, very small, their evaporation time is long. Smaller black holes would be evaporating quickly, and yes, maybe some might have evaporated already by now, but they would have such a tiny mass that it's hard to imagine it could contribute to the the background that we understand as dark matter, this stuff that is there because we can detect its gravitational influence, but we can't see it. Now, the question of what's left when a black hole evaporates is an open one, and it is really an interesting one because there isn't an answer to it. You can kind of have a look online and check out, what the remnant is of a black hole. I guess the jury is out on what is left. There is a suggestion that what you're left with is an object of tiny mass that is stable, doesn't disappear, but really nobody knows. That's the bottom line with this. My thinking was a bit different. I expected that if a black hole evaporates, basically all the mass goes and you're left with nothing, not even a singularity, because it's the mass that causes the singularity, that point of infinite density. So it seems that some physicists think something is left. It's got a tiny mass, and therefore is not in any way significant in contributing to the dark matter of the universe. That's a very sort of gobbledygook answer to a simple question. But the bottom line is nobody really knows. We don't know what the end product of Hawking radiation is. And it's very hard to find out as well. It would have to be by modeling with physical processes that we really don't understand, because we have no physics that describe what happens to a point of infinite density, which is what a black hole is. So many thanks for the question. An interesting thing to think about, but we don't know the answer.
Maybe one day one of our listeners will be the one to find that out.
That might be
And
the
if
case.
you guys have the answers, you definitely need to write in and let us know.
Roger, you're loud and clear here also.
Space nuts.
Our next question comes from James. James says, Good day, Fred, Andrew, Heidi, and Hugh. That's our producer. He doesn't always get a shout out, so that's nice. Um, James says, I've got an ethical question I'd like to propose to you in a hypothetical scenario. Let's suppose we find alien life as advanced as us, and we're able to meet in person and start sharing knowledge and culture with each other. Ethically, assuming nothing would go wrong from eating alien food, would it be acceptable for humanity to eat the cuisine of this new life? Sorry, eat the cuisine of this new life if it is equivalent to a hamburger or chicken nugget? Would we stick to their fruits and veggies, or are we going space nuts about the Andromeda Cosmic Ray fried chicken? Thanks for all you do. Fred, this one is different from our usual questions. This is an opinion.
It
Would
is.
you eat the fried chicken?
So I guess the issue is, and essentially James is making a distinction between vegetable food, fruit and veggies, or the meat, the stuff that has once been a living animal. And it's a really great question. I'd be interested to hear your thoughts on this, Heidi, because you've got as much
Oh man,
intuition
my
into
brain
this
already
idea.
started rolling as soon as this started.
Yeah. I so, let me try and put it into context. So I think ethically, here on Earth, we've got nothing that stops us from eating the food that originated with a different culture from our own, and we enjoy that. We relish the fact that we can, eat food from different cultures. Now, the difference here is that the raw material, whether it's meat or whether it's vegetable or whatever it is, has come from Earth. So we've got the same raw materials. We've just got a different process that turns it into food in this different culture. And I think that's the difference with some sort of alien. If you were invited to a meal by a friendly alien on their home planet, uh, my guess is that I don't know. Maybe I'm just being too polite here. In the interests of good relationships, you would probably do what they would ask you to do. Now, I'm taking James's caveat here that that we don't have any risks health wise, as he says, assuming nothing could go wrong from eating alien food. Would it be acceptable for humanity to eat the cuisine of this new life? If it's the equivalent of a hamburger or a chicken nugget. I think my humble opinion is that it would be that if maybe you have to broaden your mind to try and incorporate the ethical system of the species who who are looking after you, who are providing you with this. You might have a different view,
Yeah.
Heidi.
There's two things I want to say. And I'll say, so one of them falls under a philosophical bucket and the other one falls under the science bucket. So let's start with the philosophical. What we eat always comes down to, and when we're talking about these kind of instances, is there's a lot of moral questions that come down into it. Cause it's like ethically, as long as, I mean, I guess even ethics is some people do run on different ethical codes or moral codes. Religious codes can dictate our diets as well. A lot of people don't eat pork. There's cultures that don't eat beef. There's cultures that don't eat shellfish. I personally do not eat pork. I found out that they wag their tails when they're happy, and I stopped. But I found out cows do the same, and I just can't. I love cheeseburgers too much. So that aside, so the morality aside, um, sentient creatures, I mean, are we talking about eating these friendly aliens or are we talking about eating their foods? And then that just comes
Yeah.
down to the whole, well, maybe people should all be a vegan or a vegetarian because some cultures eat dogs are cats and some cultures don't. But now the scientific side of it is really interesting what NASA does in their foods lab. And I had the privilege of touring their foods lab a few years ago. I got invited as a media person to go to the Crew 7 launch. That was 2 years ago, Crew 7. And so part of that is we got to sit down with subject matter experts and we got to tour the foods lab. And thinking about the benefits of food from other planets or food grown in space, I think it's very interesting. And it's something that I would love to see. Hypothetically, if this food was better for me as a former athlete, if this is more protein and it's easier for me to consume and it's going to make me a better athlete, absolutely I would eat it. But if it's full of weird radiation that's going to give me cancer in 5 minutes, probably not. So a lot of hypotheticals here, a lot of what ifs. But fun question nonetheless.
And indeed, I think James tried to rule that out, the radioactive food, by saying that it wouldn't harm us. But yeah, it's a really interesting question. And I mean, the scientist in me is a little bit, I guess, upset by the idea of eating what you're studying, because if you're an astrobiologist, this is, and you're talking about life forms, whether they're vegetable or animal, on a different planet, then that's part of the scope of astrobiology. And should you eat what you're trying to study? I don't know. Great question, James. Like all our questions, one that gets us thinking.
0G, and I feel fine.
Space nuts.
Well, our very last question is another audio question, and this one is from Dan in California. So I'm going to go ahead and cue that question up now, and you guys can listen to Dan's question.
Hi, Heidi, Fred, and Andrew. It's Dan from California. I haven't sent in a question for a while, but I thought I would ask one about the sun. Recently, with the Parker Solar Probe getting some more data back to us, it made me think about the temperature difference between the corona and the photosphere, and whether we expect the same thing to happen to other stars that we have observed. Great show. Love every moment of it. I try and listen every time. Thank you.
Thanks, Dan. Thanks for listening. And another great question. And this is one that I think astrophysicists have got more of a handle on than the ethical question that we've just heard, or the one about evaporating black holes. Is something that we do understand at a certain level. So Dan is asking, to what extent other stars mimic the behavior of the sun, part of which is still a puzzle. And the bit I'm talking about is the fact that we have the surface of the sun, and I'm using the word surface figuratively because it doesn't have a solid surface. It's the point at which the sun, where the radiation of the sun seems to come from, the visible light, what we call the photosphere. That's around about 5,500 degrees Celsius or so. But the atmosphere above that, the outer atmosphere, the corona, which is that ethereal glow that we see when the sun is in eclipse and you can't see the photosphere is blocked out. We know the temperature of that is measured in millions of degrees. And the question that's still an active question in astrophysics, in solar physics, is how does that solar corona get to be so much hotter than the surface of the sun, the visible surface of the sun? The mechanisms are poorly understood. We think it is due to magnetic, the tangled magnetic fields on the surface of the sun. Magnetic activity is really what gives you the transport of energy from the surface up to the corona. But the exact mechanism is still basically not fully worked out. And in fact, Dan mentioned the Parker Solar Probe. It's a NASA spacecraft that is orbiting the sun more closely than any other spacecraft has, and is detecting things like these intense magnetic fields. So hopefully the physicists will sew up all those details, pull them together, and get an answer as to why the corona is so much hotter. But the point of Dan's question is not about the sun; it's about other stars. And indeed, our understanding is that other stars have this equally hot corona. Other sun-like stars, I should qualify that, because stars come in widely different varieties. But other sun-like stars, we expect to find a similar corona. Whether that has been detected directly, I'm not sure about, because we detect the corona through basically high energy radiation, X-rays and ultraviolet. They are what betray the high temperature of the corona. Whether we've been able to detect those emissions from other stars, I'm not sure, but I wouldn't mind betting that we have, because those coronas are expected to behave just as the sun's corona does. The sun's a very, very typical star. There's not really anything extraordinary about it, except it has a family of planets, one of which has an intelligent species on it, and that might even make it unique.
Well, there you go. That's a wrap with the questions. What a great bunch of questions, you guys. Thank you so much for sending those in. I think I maybe mentioned this on our last episode, but it's finally summer break for me for a few short weeks. So please keep those questions coming in so we can keep listening to them and answering them and enjoying interacting with you guys. Fred, that's the end of this Q&A episode. Do you have anything else you want to add before we sign off?
No, only to reiterate what you've just said. It's this is the thing about Space Nuts. We've got such an active, energetic, enthusiastic, and very erudite audience that it's great to hear from all our listeners. And yeah, please keep sending in the questions, audio or text. We're happy with either. And a quick thank you from me too. You mentioned him already. It's not often Hugh gets the rap, but usually from Andrew he got an insult. But we're not going to do that, Heidi. We think Hugh's doing a great job. And I'm delighted to receive a bunch of new questions from him yesterday afternoon at very short notice indeed. So thank you for that, Hugh.
Excellent. Well, thank you so much for listening, and we will see you all next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.